Hello, welcome to the bi-weekly Subspace Dev Sync. We'll be discussing some of the highlights from the last couple of weeks and things we've been working on, in addition to some kind of more general announcements. To get started, biggest news we had in the last couple of weeks and had been kind of being promised for several weeks was finally a successful launch of Gemini 3F. That officially took place on Friday to the community. So we're pretty excited to have that out there. It looks like the network continues to grow. We're approaching 1,000 nodes, like 850 nodes. So it's great to see. It looks like mostly stable. I know I do see some reports being different errors and such in the Discord, but I think most of those are not critical, but we will be looking at those and getting back to people in the Discord support. So it's exciting, Gemini 3F, if it does continue to proceed successfully, will become the first iteration of our last incentivized testnet. So that's pretty exciting stuff heading to mainnet. All right, so project highlights from the week. Let me get started with Nazar to discuss kind of proof of time, some kind of internal debates we've been having around it, and maybe open how we're going to be opening the discussion to the community. Would you mind giving an update on that, Nazar?
Yes, of course. So proof of time, for those who are not aware, is one of the latest upgrades. One of the last upgrades we'll be doing to the consensus of Subspace, at least as we plan it right now. The problem with the current consensus and generally with proof of space protocols is there is this attack called a long range attack. The idea behind it is you don't need to have more space than the rest of the network to attack the network right now. You need to have more than half of the space of the average space of the network during its lifetime. So imagine the network was live for a year and then it was growing slowly from 0 to 1 petabyte. Basically need more than half a petabyte to attack the network after 1 year. What proof of time allows us to do, it allows us to commit the history of the blockchain to the physical arrow of time, and then you need to have both half of the average space during the year, and you need to spend 1 year of time doing sequential proof of time execution. And that way we basically fix the problem. So that's why we need proof of time. That's why we are working on it. It is part of many protocols like Qi, I believe, also has proof of time. Uh, so that's the background why we need it. Now there are some challenges in terms of how to implement it, and we've been working on that for some time. And there is one challenge that we are discussing lately in particular that we'll need to input from the community on is whether we do optimistic or pessimistic verification. Basically, the proof of time we go with initially is based on AES, which is very efficiently optimized on the modern CPUs, both like Intel, AMD, and from Apple and from others. There are some special hardware instructions which were iterated on for like a decade, even more than a decade, which is great. And from our studies with some specialists in the industry, it looks like the best you can do with special ASIC is like 2-3x of what modern CPUs can do, which is not a very wide gap comparing to some of the other algorithms. So that's why we go with it. The thing is that someone with fast CPU will be producing proof of time. The rest of the network will not be able to catch up with them, but they need to verify that those proofs are actually correct. There are several ways to do about it. The most reliable and naive way is to just verify everything, but there is an energy cost associated with that. And the way modern processors are organized, they actually can do more than one thing at a time, even on the same CPU core. There are things called instruction parallelism and SIMD instructions. So basically, we can do verification faster than provers with faster processor can prove, but it is still an energy. It is still CPU time you need to spend. There is a way around that, and that way is called optimistic verification, where we just assume that those proofs are correct unless we are proven, unless someone catches that they are actually incorrect or submits a fraud proof. Um, the fraud proof mechanism makes it way more complex, and there are some interesting edge cases which wouldn't exist otherwise. And it also makes the implementation very, very challenging. So that's something we've been debating internally. Um, it would be nice to go with pessimistic verification for simplicity and reliability, but we are not sure that the community will be happy with the trade-off in terms of the energy efficiency. So we have done um, basically a research. We composed um, an article essentially that has a bunch of data points, and we'll be publishing that to the community for discussion, and we'll be collecting feedback from what community thinks about it, and that will dictate our decision going forward, what we do about it.
Great. Yeah, it's been quite a experience, kind of the discussions around this and trying to come up with more efficient ways on these verifications and running into roadblocks in lots of different places. So looking forward to that discussion. We'll also be, as part of that discussion, I think, moving forward with pessimistic in the test net phase, just to see in the wild kind of how it actually performs. In addition, if it's in line with what our internal testing has shown. All right, Nazar, again, from highlights for the week. I know you've been hard at work at lots of areas, and some of that has been around UX improvements for farming. I know some of them are a little less visible, some more visible. Would you mind just kind of highlighting what you've been working on in that space?
Yes, generally there were many things that the community was asking us about for a long time that were just long overdue. There were reasons, at least I can just like logically justify them. That there were a lot of moving parts that didn't make much sense to finalized. But now that we have some features finalized, we can actually do those improvements. There is a milestone on GitHub. If you go to the Subspace, you can see protocol UX improvements milestone. There will be more issues there. Some of the issues I want to highlight, the data that farmer stores previously involved several databases that was challenging to estimate in terms of size. It wasn't really straightforward to pre-allocate to ensure that during runtime of the farmer, it will not run out of space. That was the reason why we had actually like a fixed um, ballpark of 8% of space was actually like reserved for those databases, which was way more than actually necessary, especially after the recent protocol upgrades. That was kind of for the version 1 of the protocol of the consensus. So all of that was changed. We finally have several flat files. It's very efficient in terms of how it writes. There is not such write amplification that community reported in the initial version 1 consensus. And what it also allows us to do is to know precisely how much space we need. And when farmer starts, it will pre-allocate all of that space and it will not allocate anything else afterwards. So basically, we are guaranteed that we will not run out of space. We guarantee that all of the space that protocol needs will be reserved on the farmer side. I'm not talking about the node. Node is kind of separate. And after that, we have done some improvements. For instance, we now support plot resizing. That was something that was asked about for a very long time. Now you just can restart the farmer with different size. It will resize everything gracefully. The other thing is, since we're not using databases, we need to worry about how we write things to disk and ensure that they are actually correct and written fully. So for that reason, we have checksums for different pieces of data that farmer writes. And there is a new farmer command called scrub that will actually go through all of those files and just check that they make sense. So if something wasn't written fully, it will fail the check and it will try to correct itself. It is also helpful if you have things like, I'm not sure how common it is on SSDs, but on hard drives you can have like a broken sectors where you try to read it, but it doesn't return data. You can override it if you like don't care about the data, and it will kind of relocate it into a different piece of memory where there is a spare sector. So those things are also fixable using this method. If farmer like crashes because there are these corruptions, it will be able to fix itself. I think those are primary improvements that were already implemented. There are some others, and there are some smaller, and there are many that are still waiting to be implemented. Primarily concerned about performance. So things like slow restart of the node. It tries to locate which blocks were archived already, and it will try to re-archive them on restart to reconstruct the intermediate state of the segment. And there are some other potential improvements we can do, but those will be for another day.
Great. Thanks for that. Ved, you wanted to kind of give an overview, maybe some of the challenges we've been facing with domains and fix that's coming up, and soon be able to test the EVM, which I know, Emil's on this call. He'll be excited about that. So,
Yep.
yeah.
With Gemini 3, we had two minor issues that we faced. The first one was related to staking, where we were not doing an right epoch transition when a new domain instance was created, and that's one reason why domain one is not operational, even though it's initiated. The second issue was mostly a remnant of V1 that we never get to clean it up, and that kind of backfired during the Gemini 3F. We were able to fix that as well, but the client fix was already deployed a few days back, so it's already in the existing snapshots. We are going to create a new runtime upgrade today. The two fixes I was talking about landed in main. So once we have the runtime upgrade, the domain one and domain zero should be able to operate as per spec. Yeah, and watch how that goes from there.
Great. Well, I'll be looking forward to seeing that. So, that was all I had listed for project highlights for the week. Let's move on to Natasha. I know, with the latest Gemini 3F, you've run into an issue on the Block Explorer getting stuck. Something maybe with the balance set event. Maybe you could kind of highlight what you're seeing. And
Yeah, in reality, it's more about the status of the archive. Since now our blocks are not finalized when we index them, there is an issue that the processor is facing when trying to query the status of the archive, like the latest head that it had indexed. So one of the things that I tried was trying to, from the processor side, try to uh, fix that, remove that check, but that doesn't seem to work. I will sync with the subscript team today to see if there's another place on the archive index that I can make a change for that to be fixed, or if I need to create like a fork of the subscript processor index to make that change as well.
and this is separate from the issue you were seeing last week where we had to
Yeah,
not look at finalized. Okay.
yeah, that's different because the blocks are already being indexed in the archive, but now since they are not finalized, it looks like an status is not being um, added to the block that it needs. And I check if in the processor I could like bypass that some way, but
Yes.
I couldn't. So now maybe I will need to fork one of the projects again to fix that directly in the npm package, and we probably will end in publishing around.
Okay.
Mhm.
All right. Well, that was all I had on the agenda for this week. If there's nothing else from anybody else, we can say goodbye and we'll see you again in 2 weeks. Thanks.